Now we are doing the lab preparation of ammonia. As you all know that there is the most famous commercial preparation method, that is Haber's process, but when we talk of lab, we prepare like the ammonia in lab by this popular method, right, that is from ammonium chloride and the slaked lime. So what we do, I am just writing again the general equation, then we will just club that equation here with the apparatus. So what do we have? We have ammonium chloride and we have slaked lime. Right. So these are actually, you can say, the reactants which are used in the forming ammonia in the lab. So what we do, we just take it, we supply it with heat, and after that what we get as a result, we get ammonia plus we get CaCl2 and we get water that trickles. So this is what we get as a result of reacting the ammonium chloride and the calcium hydroxide. So now look at the apparatus, what apparatus we actually use in the lab. So see, here is a round bottom flask, as you can see it, right. Here is a tube which is connected. Here is, we have a drying tower that is made up of quicklime, and here we can just have a container in which we can collect the ammonia. Right. So actually, you know what happened, there are certain precautions, as the reaction seems to be very simple, but there are actually a few important precautions which has to be taken, otherwise the apparatus may break, right. So just look, just listen to me about the precautions which you need to take while preparing ammonia in the lab. So first of all, what we are doing, I am taking ammonium chloride and slaked lime and I am heating it, right. So is it okay? It is okay that we heat it, and on heating we get this product ammonia, CaCl2 and water vapor, right. We have to take care of this water, which is water vapor which is formed, right, or you can say the water droplets which are formed. We actually have to take a precaution against these water, right. So what happens, as you can see, we are keeping this round bottom flask in a slanting position. You know what is the reason for keeping it in a slanting position? The reason is simple, that we don't want that that the water which is formed as a result of heating may flow back, or you can say may disturb the reaction, because when it flows back it may crack the the glass of the round bottom flask. So that is why it is kept in a slanting position, so that the water which is formed just trickles down, right. It should not flow back, or it should not mix with the reactants, right. So that is the reason it is just kept in a slanting position. So it is the first precaution. What is the second precaution which has to be taken? Second precaution is that when you take ammonium chloride, just surround it with the calcium, slaked lime. This slaked lime, which actually you can say it forms a film around the, but it should form a film around the ammonium chloride, so that when as a result of heating the water is the released water droplets are released, so that means the calcium hydroxide should be able to soak that water in order to thus you can say just prevent the apparatus to crack. So these are the two precautions which has to be taken in a serious manner, right, because we don't want that our apparatus may crack or burst or something, that kind of thing happen. Right. So that means on reacting, you know that we get these things, right. So that means we just make ammonia flow through these pipes, and moreover this ammonia, as we know, as far as the solubility of ammonia is concerned, ammonia is highly soluble in water, and we are getting the water along with it, right. So there is you can say a maximum chance, 99% chance, that the ammonia may combine with water in order to form ammonium hydroxide. And what we wish to prepare in the lab, do we wish to prepare ammonium hydroxide? No, we are just looking for our ammonia, that is only the NH3, dry ammonia. So that means we need to dry that ammonia which we get as a result of the reaction. So likewise in the same way, when we want to dry that ammonia, so we need to use some drying agent. So there is a precaution while using the drying agent. One is that we have to use the drying agent that is, you can say, a basic drying agent. Do not use the acidic drying agent, because the ammonia is somehow basic in nature. So ammonia is just going to react with those acidic the drying agent, and may result in the formation, or you can say may result in a neutralization reaction. So we are in immediate need of only the ammonia, not the ammonium products, right. So that is why we use only the basic drying agent. As you can see here, we have used the quicklime. Right. So what happens when this ammonia pass through these beads of quicklime, all the moisture just get extracted and we get the pure ammonia. And you know that how ammonia is collected? Ammonia is collected by the you can say it is lighter than the air, so it just collect at the you can say above the air. So this is how we can prepare the ammonia in the lab. So three precautions you need to remember. First, then you have to keep the round bottom flask in a slanting position. You know the reason, right? Second is that we need to cover the ammonium chloride with a slaked lime. You know the reason, same, that is in both the cases we don't want that the water may flow back, or the ammonia or may crack the apparatus, or may combine with ammonia in order to result in the ammonium hydroxide, right. The third precaution is that we need to use the basic drying agent, not the acidic one, because ammonia has great affinity in combining with the acidic ones, because ammonia is itself basic in nature, so it will result in somehow neutralization reaction. So these are the three precautions which you need to remember, and moreover when you are using ammonium chloride in a slake with a slaked lime, the you can say the appropriate proportion of using is the 2:3 volume. That is, ammonium chloride should be present in 2 volume and the slaked lime should be present in 3 volume. So this is how you can say you can prepare ammonia in the lab.